All right, so we're talking about slope, and we know that slope and rate of change are the same thing. So, excuse me. So when we talk about slope, we're talking about rate of change, changing y over changing x. But specifically, when we're talking about slope, the mathematical definition is not changing y over changing x, though it is. It is now evolved to rise over run. Changing y is rise, changing x is run. So slope is rise over run. So we have to be versatile and understand the terminology. So we're talking about finding the slope from any 2 points. Now, so if we're given a line and we need to find the slope of that line from the 2 points, we can always use on a graph, and I'm gonna always tell you in a graph, use rise over run, y'all. So, excuse me, I'm feeling a little bit under the weather. If I look at this point and I look at this point here, whatever I write, you write, and please, y'all, please listen to learn. Do not just put captions on. Do not just fast forward my voice, because if I talk that fast in class, you wouldn't get it. So don't act like if I'm talking now that you'll get it. So listen to learn. We practice for mastery, not just to pass. So listen for mastery. All right, that's out of the way. So if I wanted to find the slope of this line, I know that the dot will be here. I could put a dot here. If I write it, you write it, and I can put a dot here. So if I looked at the slope of this line, I know that we learned that if it's rising to the left, it is a negative slope. So I am going down 2, and this time it is 2 because it's 6, 5, 4, to the right 1, and that is 1. So the slope of this dot line is negative 2 over 1. If you give it a graph, everybody, we're going to always do that. That's the easiest thing to do. We can do what we're about to do, and it works more so for a table and a set of ordered pairs more so than a graph. But I'm proving that's the case from the graph. So what if you're just given these two ordered pairs, 0, 6, and 3, 0? If you're just given these two ordered pairs, we use subscripts to distinguish. We must use subscripts to distinguish between the two values. That's all subscripts are used for, is to distinguish between the two values. So we have an XY here, and we got an XY there, right? We have an XY. This is technically XY. This is technically XY, right? So we have two XYs. So if I want to talk about 0, 6, well, 0, 6 is an X and a Y. I'm going to call this the first order pair. So I'm going to say this is X sub 1, Y sub 1. This is X sub 2, Y sub 2. Sub is for subscript. And the only reason why we use subscripts is to distinguish between the two values. You have an XY and an XY. So if I want to talk about 0, 6, I'll say 0, 6 is X sub 1, X, Y sub 1. 3, 0 is X sub 2, Y sub 2. Know this. Why did we use subscripts to distinguish between the two values? Why do we use subscripts to distinguish between the two values? Why do we use subscripts? To distinguish between the two values. So if I'm given two ordered pairs and I need to find the slope, instead of graphing them, I can use the slope formula. This is called the slope formula. What is the slope formula? Y sub 2 minus Y sub 1 over X sub 2 minus X sub 1. All we're doing is just rise over run. Or in the land of rate of change, changing Y over changing X. How the Y is changing, how the X is changing. That's how we've always done it. So if we're using two order pairs, we're just basically saying, hey, find the change in Y's, this minus this, over the change in x's, this minus this, and that's your slope. And so if I do this, this represents X sub 1. Sorry. Just made a mistake. It doesn't represent X sub 1, y'all. The first order pair represents Y sub 2 minus Y sub 1 over X sub 2 minus X sub 1. That's all we did. So it doesn't matter which one you label first. The ones or the twos, it doesn't matter because you're still finding the slope of the line. It's a constant rate of change. That's why it's linear. So it doesn't really matter which order pair you label 1 or 2. I'm sorry for coughing all in your ears. All right. So this is 0 minus 6 over 3 minus 0, 3 minus 0. 0 minus 6 is negative 6. 3 minus 0 is 3. Negative 6 divided by 3 is negative 2 over 1, technically. All right, which is the same thing we get from the graph. All right, so this is going to make more sense as we move on. But again, this is simply the change in y's over the change in x's. So y sub 2 minus y sub 1 over x sub 2 minus x sub 1. We label x sub 1, y sub 1, x sub 2, y sub 2, and we just plug them in where they go. Y sub 2 goes here. Y sub 1 goes there. X sub 2 goes there. X sub 1 goes there. If I write it, you write it. All right, let's get to work. So here we are, and it says, do I want to do this first? I'm gonna come back to this, because I just feel like we should practice first. All right, it says find the slope of a line through negative 2, 1 and 5, 7. All right, so since these are first, I'm just gonna label these ones, x sub 1, y sub 1. I'm gonna label these 2's, x sub 2, y sub 2. Again, I'm going to show you in a minute. It doesn't matter which one we label first. We just label them like that because we just saw them come first. All right, so let's use the slope formula. Y sub 2 is first, so that's 7. 7 minus y sub 1 is 1 over x sub 2 is 5 minus x sub 1 is negative 2. So this is 5 minus negative 2. Please don't forget that. All right, we have the twins. We make them Siamese. And so we have 7 minus 1 is 6. 5 plus 2 is 7. So what does this mean? It means we rise up 6 and we run right 7. If we were to graph this, that would be the slope. All right, find the slope of the line through negative 2, 5, and 8, 2. Let's label x sub 1, y sub 1, subscripts to distinguish between the values. X sub 2, y sub 2. Let's plug them in. 2 minus y sub 1 is 5 over 8 minus x sub 2 is negative 2. Twinning. So 2 minus 5 is negative 3. 8 plus 2 is 10. That means we go down and then we go to the right. All right, let's label x sub 1, y sub 1, x sub 2, y sub 2. So we have 7 minus negative 3, twinning, over 7 minus negative 4, twinning. 7 plus 3 is 10. 7 plus 4 is 11. We go up to the right. Last one. X sub 1, y sub 1, x sub 2, y sub 2. The formula is y sub 2 minus y sub 1. Rise over run, which equates to the change in the y's over the change in the x's. Okay? If I write it, you write it. So 3 minus 5 over 0 minus negative 1. Twinning. So we get 3 minus 5 is negative 2. 0 plus 1 is 1. And so we get the slope is negative 2 over 1 means goes, excuse me, down 2 to the right 1. And so I said I was going to show you all that if you label them differently, you'll be fine. You don't have to write this down. Don't write this down, but do watch. Wrong thing. Do watch this. You don't have to write it down. Come on. Erase. 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 I got too much stuff on this computer. You don't want to act right. All right, there we go. Erase my stuff. So say, for instance, I say, hey, I let this be the ones, x sub 1, y sub 1, and this is x sub 2, y sub 2. So if I do this, if I did that, I'll get 1 minus 7, y sub 2 minus y sub 1, over negative 2 minus 5. 1 minus 7 is a negative 6. Negative 2 minus 5 is a negative 7. And a negative over negative equals a positive. So you still get the same answer, because this is the rate of change of the line. Okay. All right, now let's go learn some acronyms. That's going to help our life out. So horizontal lines. Think of a bicyclist on a flat road, horizontal line. He or she would have no problem, right? No slope. There's no steepness. So there's no slope. There's no rise. There's just a run. And so whenever we have a horizontal line, the way we can remember this, there's an acronym called HOY, H0Y. So this is a 0, not necessarily a O, as in O'Neill, but H0Y. So horizontal line with a slope of 0, and it crosses the y-axis. So when you want to remember the acronym, to remember that this is horizontal line has a slope of 0. Okay. Horizontal line has a slope of 0. There is no steepness. There is no rise. So the slope is 0. The way we can do this, we can also figure this out. I'm writing, you're writing. If I call this x sub 1, y sub 1, x sub 2, y sub 2, and I'll come over here and use my formula. If I go 4 minus 4 over 5 minus 2, I get 0 over 3. Which means rise none, run 3. Y'all see that? Don't rise, run 3. 1, 2, 3. Which means that 0, 3 will always give us a slope of 0. Okay? Now, if I look at here, vertical undefined x crosses the x-axis. We went over undefined slopes yesterday, but this is just a way to remember it. So let's look at this. It's impossible for a bicyclist unless you have superpowers. Stan Lee passed away recently, so yeah, he wrote a lot of comic books. But here we're not talking about superpowers. We're just talking about if you try to ride a bike up a vertical side of a wall, it would be impossible to do that with just this bike because of gravity will be pulling you down. Okay. So if that would happen, since it's impossible, we call this an undefined slope. Undefined slopes are vertical lines. We remember this by the acronym of VUX, V-U-X. So we looked at our formula, x sub 1, y sub 1, x sub 2, y sub 2. We can use the formula to find the slope. So we can say negative 2 minus 3 over 4 minus 4 is negative 5 over 0. Now, this is why this is impossible. It's impossible to take something and divide it into nothing, right? It's impossible to take something and split it into nothing. That's why this is impossible. This is called undefined. Impossible to take something and turn it into nothing. Impossible. Okay? So HOY, VUX, vertical undefined, crosses the x-axis. It also crosses the x-axis, but the equation is wherever it crosses the x-axis. This is a bonus. So x is equal to 1, 2, 3, 4. And we saw that in the linear, nonlinear, all your x's are 4. So all the x's are 4. So this is definitely not a function, but it is linear. Not a function, but it is linear. So VUX, vertical, undefined, x-axis, also x equal equation. HOY, horizontal, 0 slope, y crosses the y-axis. Guess what this equation is? I'm going to let the strong connectors. X equals 4 is this equation because it crosses the x-axis at 4. X equals x-axis. Y equals what? 4. Because it crosses the y-axis at 4. Look at the y-order pairs. Both are 4s. Look at the x-order pairs. Both are 4s. Hint, hint, hint. Hint, hint, hint for the future. All right. And to wrap this video up, so it'll be done in 20 minutes so y'all can do some work by yourselves. Keep it moving. So it says find the constant rate of change or the slope. Now, everyone, when you have a table, I'm telling y'all, when y'all have a table, I'm going to take them out showing that you can use the formula. But y'all, we don't have to use the formula for the table. We can do what we've been doing. Changing y over changing x is the same thing as the slope. But again, I'm going to show you. We can take out two order pairs. We can call this x sub 1, x sub 2, y sub 1, y sub 2. So if we want to find the rate of change in the table, all we have to do is negative 3 minus negative 6 over 5 minus 1. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Twinning. This will give us 3 over 4. So the slope of this is 3/4. Y'all watch this. Rate of change. How does 0 become 3? Add 3. How does 9 become 13? Add 4. What's the slope? Change in y over the change in x. Rise over run 3 over 4. Okay? Same, y'all. Oh, I just want you to get it. It's the same thing. You don't have to be confused. You really don't. You can use this. Or you can use this. You will get the same answer. All right, let's move on. The tiers. Okay, so again, if I wanted to use the formula, I can. Okay, so this is x sub 1, x sub 2, y sub 1, y sub 2. Some of y'all might want to go x sub 1, y sub 1, x sub 2, y sub 2. You know, doesn't matter to me. But then why do we use subscript? To distinguish between the values. 4 minus 7 over negative 1 minus negative 3. Twinning. And we get 4 minus 7 is negative 3. And then negative 1 plus 3 is 2. Watch this. How does 1 become negative 2? Well, you subtract 3. How does 1 become 3? You add 2. What's the slope of this line? Negative 3 over 2. Okay? Find the rate of change. The rate of change is constant in the table. Find the rate of change. Explain what the rate of change means in the situation. It's constant. Hey, it's linear. Constant means linear. It is linear. Okay? So, I'm not going to pull out the order pairs. How does 75 become 100? Add 25. How does 3 become 1? Sorry, 3 become 4. Add 1. So, what's the slope of this line? It's 25 over 1. What does that mean? It means 25, I should say it cost, whatever it is, it costs $25 each day. Okay? Now, over here, how does 232 become 348? Well, you know, you might want to subtract that if you can't figure it out in your head. 348 minus 232, y sub 2, y sub 1. This is exactly what we're doing, y'all. 8 minus 2 is 6. 4 minus 3 is 1. 3 minus 2 is 1. 116. How does 4 become 6? 6 minus 4 is 2. Or 4 plus 2 is 6. Divided by 2. Divide those. We want to simplify this. 58 over 1. What does that mean? 58 miles per or each hour. All right. So this last page, before you get to your worksheet, as it moves on. Dun, dun, dun. All right, so find the constant rate of change slope if the relation is linear. So we have to see if the relation is linear. If it is, y'all, this is going to be beyond easy. 1 becomes negative 2 by subtracting 3. Negative 2 becomes negative 5 by subtracting 3. Negative 5 becomes negative 8 by subtracting 3. All right. 3 becomes 4 by adding 1. 4 becomes 5 by adding 1. 5 becomes 6 by adding 1. What's the slope? Negative 3 over 1. Linear. Why? Because the rate of change is constant. Because the rate of change is constant. Because the rate of change is constant. Because the slope is constant. All right. How does 0 become 1? 1. How does 1 become 4? Add 3. How does 4 become 9? Add 5. It doesn't matter that these numbers are not constant. It's the ratio. Are the ratios the same? Okay. Okay. So 2 become 4, adding 2. 4 becomes 6, adding 2. 6 becomes 8, adding 2. No, non-linear. And it's not because these numbers are not the same. It's that the 1 over 2, 1/2, is not equal. It's not the same as 3/2. That is the reason why it's not linear. It is not because these are 1, 3, and 5. It's because 1 over 2 is not the same as 3 over 2. All right. 5 becomes 8. Oh, I'm over my 20 minutes. Oh, well, get over it. 5 becomes 8 by adding 3. 8 becomes 12 by adding 4. 12 becomes 17 by adding 5. Negative 3 becomes negative 1 by adding 2. Negative 1 becomes 1 by adding 2. And then 1 becomes 3 by adding 2. So, clearly, 3 over 2 is not the same, nonlinear. 3 over 2 is not the same as 4 over 2. And let's look at the last one. 3 becomes 6 by adding 3. Adding 3. Adding 3. Adding 1. 1. 1. Linear. 3 over 1 is equal to 3 over 1. All right, so I'm done. I know you enjoyed this video. I know you enjoyed hearing my voice. Your teacher's out, and I know you're sad. You just wish I was here today, but I was here in video. Mr. O'Neal is out. It's been another B Smoke production, and I'll see you later. Have a great life. I will see you all on Monday. Be safe. Be great.